Good afternoon, everyone. I am Wampeewo of Wampeewo Ntakke Senior Secondary School, and I'm going to be presenting number 14 of the mechanics question, paper 2, which says that a smooth bead of mass 0.2 kilograms is threaded on a smooth circular coil of radius r meters, which is held in a vertical plane. If the bead is projected from the lowest point on the circle with a speed root of 3 rg, find the, well, let us first sketch this case scenario, which is let this be the circular thread, a smooth circular wire, having a radius r. Now the bead is at the lowest point of this circular wire, and it is projected, it is given an initial velocity of 3, but this is under the root, and I'm going to have its weight acting downwards. It is 0.2. They told us find. Now at this point, there is a tendency of the normal reaction which acts towards the center of this circular wire R. They say like find the speed of the bead when it has gone a 6th weight round the circle. Now we know that round the circle or around any circular path, the distance or the angular distance covered, it is going to be 2 pi. That is 360 degrees. So when it has gone a 6th way, I'm going to have a 6 times. Now I'm getting the angle. It is a 6 times 2 pi. So I'm going to have pi by 3. Now let me see. If it has moved a 6th way, let it be at such a point. With now a speed v. That is our theta. So when it is at such a point, this, we are going to use the principle of conservation of energy. Let me call this point A. Let me call this point B. So when it is at point A, I'm going to say that it only has kinetic energy. Our kinetic energy is given by formula mv squared. So I'm going to have its mass is 0.2. Its initial velocity v squared, it is root 3 gr but squared. So I'm going to have 0.1. So I'm going to have 0.1 times 3 gr, which is 0.3 gr joules. That is the kinetic energy. But the potential energy at A, it is 0, since it has not covered any vertical height. So at point B, I'm going to consider that since this is r, that means this distance is r cos theta. That means the remaining distance between B and A, I'm going to have this distance here is going to be r into 1 minus cos theta. Isn't it? So you come and consider at B. At B, it has attained a velocity v, so its kinetic energy is going to be given by 0.2 times half v squared. So this is going to be 0.1 v squared. That's the kinetic energy. But then at point B, it has also the potential energy, of which potential energy is given by mgh, of which our m is 0.2. our G is, we can leave it there, then our H is R1 minus cos theta. 0.2 times D. But remember, we had got our angle as 5/3. So our 5/3, we are going to put it here. 1 minus cos 5/3, which is the same as 60 degrees, and cos of 60 degrees, that is a half. A half, 1 minus a half, I'm going to remain with a half. So I'm going to have 0.2 GR times a half, isn't it? So I'm going to have it that this is 0.1 GR. This is joules. These are joules. So by conservation of mechanical energy, I'm going to have that the mechanical energy, the total mechanical energy at A is equal to the total mechanical energy at B, which is given by 0.3 GR is equal to 0.1 B squared plus 0.1 GR. You can take this GR this side, so I have my 0.1 B squared, which is equal to 0.2 GR. Sorry, it's 0.2. We divide through by 0.1. I'm going to have my B squared is equal to 2 GR. Therefore, my V is 2 GR. That will be the speed at a point situated around the south. Now for part B, they say find the force exerted by the feed at this point. Now the force exerted, we are going to imagine that at this point, this speed had its weight act downwards, 0.2 G, and of which this weight was acting at an angle theta, which is 5/6. So theta, so here I'm going to have that 0.2 G cos of theta. And here I have the normal reaction. So they have told us to find the force at this point. So I'm going to have by applying F is equal to ma. That is Newton's second law of motion. So I'm going to have R minus 0.2 G cos theta is going to equal to 0.2. Remember, this force that is given for a body moving in a circular path, it is the centripetal force. Of which centripetal force it is 0, the mass 0.2 times the velocity, which is the velocity squared. It is given by F is given by mv squared over r. So I'm going to have the velocity squared, which is times 2 gr all over the radius, which is r. But remember we had got that this r can cancel out. Remember we had got that our theta is 5/3. So I'm going to have 0.4 G this minus 0, sorry, plus 0.2 G times a half. I'm going to have my R as 0.4 G plus 0.1 G. So I'm going to have 0.5 times the 9.8, which is our G. So I'm going to have 4.9 newtons, which is the force at that point. Thank you very much. I remain Mwanguzi Fortune of Wampeewo Ntakke.
Thank you, Mwanguzi, for the presentation. Please, any comments for Wampeewo, put them in the chat.